So we are now going to take a look at section 1.3. And section 1.3 is called Inequalities. Let's take a very, very basic concept. X is greater than 5. X is greater than or equal to 5. Actually, let's do both of these. Okay, now what does this mean? If you looked at a number line, see, we always use the number line. If you use the number line, what we're talking about is all the numbers greater than or equal to 5. All the numbers greater than or equal to. This line underneath here means equal to. And when you have that line, it means that you shade in the 0.5. When there's no line underneath the equal sign, then it's an open circle. Again, when there's a line underneath, and sometimes it's one line, sometimes it's two lines, but not too often. I don't see this that often. It's true, but I just don't see it that much. So we just have one line. Mathematicians try to be as succinct as possible. So one line serves the purpose. When there's a line underneath, it's a shaded in circle. When there's no line underneath, it's an open circle. And then it's going to be all these values, 6, 7, 8, 9, going in that direction. 6, 7, 8, 9. That's what it means. This is the inequality. This is the number line representation. And there's a third way we're going to represent an inequality, the values of a number in an inequality. And that method is called interval notation. Interval notation means that because this is a shaded in circle here, we use brackets. And let me see, this number line, let me draw a number line the way you're going to see it in the future. This is infinity. This is negative infinity. Here's the 5. Here's the shaded in circle. This is what it looks like. See, that's what this looks like. This goes like this. This goes like this. So this, could be written like that. And this is interval notation. This shaded in circle has a bracket. And we put the 5. And then it goes all the way out to infinity. So we put infinity and we use parentheses. See, there's two ways. There's brackets and parentheses. If it's shaded in, this shading in means we use brackets. Infinity always has a parentheses because nobody knows where infinity is. We all think we have an idea that it's all the way out somewhere, but nobody has ever been there and come back to talk about it. Here, on the other hand, since this is an open circle, we don't use brackets, we use parentheses. So once again, this is the inequality, this is the number line, this is interval notation. If it's a shaded in circle, based on the fact that there's a line underneath there, the line underneath means shaded in circle. The shaded in circle means the 5 is in a bracket. And the infinity is always going to be parentheses. When there's no line underneath, and this is an open circle, then this is a parentheses as well. And that's always going to have that. Let's try x less than or equal to 5 and x less than 5. And I'll give you a moment to do two things. Show what this looks like and what this looks like on a number line, and then write it in interval notation. Let's begin. First, let's create a number line. The number line doesn't have to be a thing of beauty, you know? You should always put the basic points though, like a 0, like infinity, like negative infinity. These are important things. And then, you're going to put the 5, obviously, and it's going to be shaded in because there's a line under there. So it's shaded in. Okay. It's going to go in this direction because it's less than. And that's what it looks like on a number line. In interval notation, it's going to be negative infinity with parentheses, and then 5 with brackets. That's the answer to that part of the question.
Why does the negative infinity get a parentheses instead of a bracket?
Because no one ever gets there. If you can get there, and it has, this means that 5 is included. But infinity is just, have you ever been there? No,
No.
nobody's ever been to infinity, so it gets a parentheses. When somebody gets there someday and then comes back to talk about it, then it'll get a bracket. But for now, it gets a parentheses.
I have a question.
Yes, Marvin.
Yeah, what if you wrote it bracket 5, negative infinity parentheses?
Good
Would
question.
that be considered wrong?
Excellent question. Here's Marvin's question. Well, it looks strange to me. It looks strange because of this, over here. Like, it just kind of shows that it's not wrong.
But when you start
Whoa,
to
whoa,
graph
whoa, whoa,
that,
whoa, 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 Marvin, we're still doing Marvin now.
sorry.
Marvin. I wouldn't mark it wrong, but if it's not too much difficulty, get used to this. Okay? That's the answer to the question. Now, Stephanie.
Thank you.
Oh, I was just thinking because when you start to graph it, doesn't like one side equal the the y-axle and the x-axle? Like, isn't it
I don't want to
specifically?
talk about the axes. I don't even want to get into the axes right now. Okay, let's stick with where we are. We're dealing simply with linear, concepts and one number line. Okay, so Stephanie's referring to this type of a situation. And I don't want to get into that at all, really. We'll talk about that soon, soon, but not right now. Okay, there was another question though, Kariatu.
Sorry, it was my headphone. I said, so we have to use always parentheses for infinity?
Yes, correct.
Okay, thank you.
Positive infinity and negative infinity, yes.
Okay, thank you.
You're very welcome. Anybody else? Okay. So for this one, same thing. Negative infinity, positive infinity. You don't even have to put the positive, obviously. Here's the 5. Open circle, no line underneath, open circle. And we shade it in going to the left. And once again, negative infinity to 5. and this is a parentheses. The closed in dot, the line underneath the inequality means bracket. No line, no shading in, parentheses. That's the beginning of inequalities. Okay, now what we'd like to do is solve an inequality equation. Solving an inequality. For example, now the question becomes, gee, that looks awfully similar to 5x equals -65. And if we had a problem like this, you would solve it by dividing by 5 and you get an answer. So the question is, everything we could do to an equation, can we also do to an inequality? Well, let's see if that's true. Let's take a typical inequality. 8 is greater than 4. Can we add to an inequality? Is that going to change the sign in any way? 12, 8, 12 is greater than 8? Well, that's true. You could obviously add. Can you subtract? -6, -6. So this is 2 greater than -2. Is that true? Yes, it is true. Therefore, you can add to an inequality and it doesn't do anything to the inequality. You could subtract from the inequality and it doesn't do anything. Can you multiply? 8 is greater than 4. Can you multiply by 2? You get 16 greater than 8. Is that true? Yeah, that's true. So you could multiply. How about divide? Can you divide in an inequality? 4 is greater than 2? Yeah. It looks like you could do all 4 operations, doesn't it? So that looks pretty good. So when we're solving an inequality, it looks like everything we do to an equation, we could do to an inequality. But it's not completely true. Because if 8 is greater than 4 and we divide by -2, not +2, like here we divided by +2, it looked pretty good, but what if we divide by negative numbers? What happens? Well, this becomes -4, this becomes -2. Is it still true that -4 is greater than -2?
No.
It is not. And it is also not true when you multiply. This isn't true either. In other words, -4 is not greater than -2. -4 is less than -2. -16 is not greater than -8. -16 is less than -8. Therefore, we come to a very, very important rule. And the rule is when you multiply or divide an inequality by a negative number, then the inequality symbol, let's just call it the inequality, reverses. This is of utmost importance. Put stars on it. You know, whatever you do when you indicate something is really, really important. When you multiply or divide an inequality by a negative number, then the inequality reverses. Okay, now let's solve some of these things, okay? So now we go back to the problem we were doing here, the original problem. And let's solve it. Well, you know, let's do it the same way we were doing it when we were doing an equation, which is to rewrite the problem. Divide by 5. Divide by 5. What do we get? X greater than or equal to negative 13. Graph it. You're always required to graph it. Well, and you have to be strategic, you know, be smart about it. We need a negative 13, so we're not going to put the 0 over there. We're going to put the 0 over there. Put the negative 13 over here. A closed-in circle. Shaded in all the way to the right. The inequality, the absolute value, and the interval notation. Bracket, negative 13 to infinity. There it is. Do that problem on your own, please. And express your answer as an inequality on the number line and interval notation, the big three. My first step is always to rewrite the problem when I remember. Sometimes I don't remember, you know. All right, well, let's see what we do first. We do this first. Get rid of the 7. We still want to isolate the variable. I got to go back this way. I'm sorry, Michelle. And negative 2x is greater than 10. Now we divide by negative 2. That cancels out. This becomes negative 5. And what happens to the inequality symbol?
The
X
reverse.
reverse.
All right, well, you got to be fast, huh? So I think Andrew was first to go there, but okay. Yes. Okay, so instead of that way, it's now that way. We divide by a negative number, the inequality symbol reverses. This is the answer right here. And this becomes, now let's see, we're working with a negative 5. Let's put the 0 over there. Let's put the negative 5. Open circle, right? Open circle. Everything in this direction, negative infinity, positive infinity. And in interval notation, that will be, see, I go in order. I'm going in order here. So the earlier question was, can you, go out of order? Nobody's going to be too angry at you. Let's put it that way. But, it's nice that it's in the same order as the number line. I like to think of the number line and the interval notation. This is like, they're like, cousins, very close cousins. That's it. Okay? Anybody have something on their mind in regard to this problem?
Can you go over the open circle one? Like I shaded it.
Okay,
I
you
shaded.
don't shade it because there's no line underneath here.
Oh yeah. Oh wow. Okay. No,
Yes, but outstanding question. Really, I mean, that's a clarifying question that is urgently important in this particular situation. This were a 10-point, 8-point question on a test. And you put, you shaded it in and then put brackets over there. That's like, that's a major mistake. You're gonna lose at least 2 or 3 points. You don't want to do that. You don't want to make mistakes like that. I mean, you don't want to make mistakes, period, but you don't want to make a mistake like that.
I have a
That was
question.
a wonderful, wonderful question. Yes, who's next? Michelle, yes.
Yeah, I just wanted to clarify because I almost forgot to reverse the sign to flip it. So, um, that's with every time we do that, we have to reverse the symbol just to be sure.
Anytime you divide or multiply by a negative number, that's what we did right here. We divide it. You reverse it.
So
Yeah.
only with a negative number.
Only when you're multiplying or dividing by a number which has a negative sign in front of it. Yes,
Okay, I got it. Thank you.
good.
Professor, I
Another
have a question.
outstanding point, because you're repeating something that will help other people. Stephanie, go ahead.
What would be an example of multiplying
Well, that's a very
multiplying
good
instead of
question.
dividing?
That's when I said when you divide by a negative number, I almost was thinking, forget about multiplication. That doesn't happen that often. It doesn't. It doesn't happen that often. So, it just doesn't happen that often. I can't even give you an example because I can't think of an example. I mean, I can dig something up, but it's gonna be obscure and maybe not even important to your life or the course in any way, so I'd rather not. But I mean, I'm giving you a rule, and the rule has to be comprehensive. So if I just said when you divide by a negative number, that's an incomplete rule. So I gave you multiply also. But really, this is the key word because this is what we do most of the time. Good question. Sorry, I can't give you an answer. I mean, but so you could do this problem by multiplying by a -1, right? But you could also do the same exact problem by putting a 1 in front of that x, right? And dividing by it. So there you are dividing again. Incidentally, that's a negative. The negative times the negative is positive. The negative times the positive is negative. That's a -5. That doesn't matter in this particular case. But I mean, that's an example of when you would multiply. But anything that you can multiply, you could pretty much, convert to division. So it doesn't matter. What a good question.
Thank you, that clarifies.
3 really, I mean, come on, those were 3 wonderful questions. That's why I love questions, because number one, people are thinking. Number two, it helps everybody. You're not just helping yourself. There's 24 people here. You're helping somebody else as well. Plus, it gives me something to do that's interesting. I like when people ask questions. Like the question Stephanie just asked, wow, that was, very thought-provoking. Can you give us an example where where you multiply? Well, there it is, but you could also, make it division. So what difference does it make? I don't know. It's important for the rule because the rule should be comprehensive. And if you don't include everything, it's not comprehensive. Okay, I'm going to move on. And I'm going to erase the board and put a problem on the board, but I'm not giving this concept a title. We're still in 1.3, but I'm not going to give the concept that I'm doing a name until after I've done a few problems. So let me go back to the beginning here. Okay, here are your instructions. Graph on a number line. These are the instructions for this problem. I'll give you a moment. I'm going to begin. So this is what you should be doing. You should be drawing a number line. Start it out by putting all the things that are important. Now you're talking about a 2 and a 7. So we could put the 0 sort of on the side. Instead of putting it in the middle, well, that's just going to cramp your style here. So let's put the 2 here, the 7 here, both open circles. X is greater than 2 will sort of look like this. Since I'm going to do 2 graphs on the same number line, I need to figure out a way that they don't intrude on each other, right? So X greater than 2, that's what it looks like. And 7, X less than 7, will be this going in the opposite direction. I mean, if you insist, you could just say, well, okay, this goes all the way out to here because it's greater than 2. This goes all the way, this is an open circle. So we're going all the way back here and there's an overlap. Where's the overlap? Right here. From this point, these 2 lines overlap. And there it is, right in there. In other words, rewriting this so it looks like, presentable. This is what it looks like. Any number which is greater than 2, less than 7, this is what it looks like. And in interval notation, this is what it looks like. This is called a compound inequality. It's called a compound inequality because you're taking into account 2 different inequalities, but you're putting them in on the same number line, and that's what it is. Now, before we analyze this further, I'd like you to do the same thing for this problem. So this is your first step, is to create a number line, label it with the infinities, with a 0 for reference, and then the 2 actual points that you're dealing with here. Now, this one means that starting at 2, we want everything less than 2. This one means x is greater than 7, an open circle at 7. Everything going in this direction. There's no overlap. When the word is and, there will be an overlap. When the word is or, they go in opposite directions. Again, when the word and is in this problem, the solution will be between the 2 points. When the word or is in a problem, one goes one way, one goes the other way. And in interval notation, watch very carefully. I know people are writing, taking notes, all that. Stop for a minute and just watch. Negative infinity, in parentheses, 2 in parentheses, because it's not shaded in, there's no equal sign. And also, or 7 to infinity. And instead of using the word or, we use this symbol. So if I were a student now, I would be just kind of, trying to digest this whole thing that just took place. And looking for patterns, and the pattern you should look for is and means that they're between. Oh, there's an overlap of the 2 solutions. Or means they go either this way or that way. If you pick a number less than 2, like 0, for example, 0 only works for x less than 2. It's not going to work here. When x is greater than 7, you go nowhere near 0. So that's not part of the solution. In this problem, you could pick something in between, like 5. 5 is greater than 2, but 5 is also less than 7.
Question.
I would
Uh,
imagine, yes.
so I know the U is instead of or you put the U. Does that have like a specific name, that symbol, or it just means or?
It certainly is. It's called disjunction. That was, you preempted me by about 15 seconds. Disjunction.
Okay, thank you.
That means or. When they're the and means conjunction. But you don't use the conjunction symbol for that for some reason. I don't know. You just don't. Conjunction is the upside down U. But you don't use that. You don't use that. Excellent question. Wow. I'm really I'm overwhelmed by the intelligence and the way you're wording your questions and you're asking it. It's just beautiful. It really, really is fantastic to the people who've been, asking questions so far. That was a great question. Well, does that have a name? Yes, disjunction. Beautiful. Okay. Let's solve a problem.
Professor, I'm sorry, really quickly, the
Whoa,
conjunction.
whoa. Next time you ask a question, forget the I'm sorry.
Um, the before the just conjunction, what was the term you used?
Before what?
The and, referring to the and,
Oh,
you said another term.
Yeah, I call that conjunction.
Conjunction, thank you.
But people don't use that, you know, that, in other words, you could. I don't see it that often. It's like, it's that's conjunction. This is disjunction. That's more of a term that's used in a different concept known as logic. And we just don't get into that much, but, well, but this will come into play a lot, so that's why we use it. Okay, here's a problem. I believe this is in the book, but I'm not totally sure, but I'm changing it a little bit. And the question is, solve for n. And when I say solve, I mean, you know, express it as an inequality, express it using the number line, and also express it using interval notation. I'm not sure you're gonna have much success with this. I shouldn't say that, but there's two ways of solving this problem. That's all I'm gonna say. There's two ways of solving this problem. So you could solve this problem in two parts. You could do this, cover up that part of it, and just say, all right, -2 is less than or equal to m minus 5. And, you know, do it the way we normally would do it. That's one possible part of it. So, and what we're saying is m minus 5 is greater than or equal to -2, and at the same time, less than 2. So it's an and situation. Well, and then we could just do the other part, which is this, and less than 7. And if you put them together on a number line, the two key numbers are 3 and 7 this time. And m is greater than or equal to 3, a shaded in circle, going in this direction. But here, m is less than 7. Shoot. M is less than 7. So, and this is an open circle, and this is going in that direction. The solution is right in here between these two numbers. In other words, m is less than 7 and greater than or equal to 3. That's the solution. And in interval notation, this is what it would look like. But I kept trying to say, when should the but come in? And here it is. This can be solved. This can be solved. This is the problem we just did. And we separated it into two parts. But you didn't have to separate it into two parts, because all you had to do was do the +5 in both places. See what I did? You're doing everything together rather than separating it the way I did down here. I separated them. But here, I'm doing it at the same time. And you wind up with a 3, an M, and a 7. Same answer. Same answer as what we had down here, except a lot easier, right? A lot easier. So you may say, well, why didn't you just show us that to begin with? That's not, in order to appreciate the beauty of this method, you had to do it the long way. Now you could do it this way if you get a problem like that. Same number line. Same number line. 3, 7, shaded in, open, and goes right in between. So this is how you would solve this type of problem. A compound inequality. Ooh, when the class is quiet like this, it spooks me out. I'm spooked.
I have a question.
Thank God.
Sorry. So, so you see on the number line how you did the shading in between the lines from 3 to 7. What happens if we don't shade it? Is it
Well, if you
still
don't
okay?
shade it, then you're basically saying, like, if you just do this, you're sort of saying there's two answers to this question. Either, M could equal 3 or M could equal 7. This is saying all these things in between are also the solution. Like 4, like 5, like 6, like 4.5.
Okay, because on the bottom one, you did like I think you did like kind of like a box like on the top. Is that like good too?
No, I included, I went like this. I showed that it's going in both directions.
Oh, okay.
Inequalities always, include things in other places as well. It's not just those 2 points, it's everything in between. Those are the 2 endpoints, but it's everything in between.
Gotcha. Thank you.
One more problem. Similar. I may have enough room. Well, let me get rid of this, if I may, because I need a little more room, and I think that any little bit of room would be just so welcome at this point. So here's the problem. X plus 5 less than or equal to -2, or the big or, X plus 5 is greater than or equal to +2. Okay, solve for X. Solve for X, draw us a nice number line, and express the answer in interval notation. Okay, I'm solving them. I'm doing -5, -5. Apparently, I left out something here. I left out a negative. See, I copied this over there and left out a negative. So I put that back again. X, this drops out, less than or equal to -7. This is one part of the compound inequality. X less than or equal to -7. And the other part is -5 on both sides. X is greater than or equal to -3. What did I do wrong? Oh, no, nothing. Thought I left out another negative sign, but I didn't. Okay. Now, on a number line, this is what it looks like. No, that's a pathetic straight line. That's not even close to being a straight line. Okay, so this time we're dealing with negatives, so -3, -7, negative infinity, positive infinity. X is less than or equal to -7, shaded in because of the line underneath the inequality symbol. And it goes in this direction. Where does it wind up? It winds up in negative infinity. This is also shaded in. Starts at -3 and gets larger than that, so it goes to positive infinity. This is what the number line will look like. And in interval notation, it will be negative infinity to -7, or -3 to infinity. That's the complete problem. Sort of squashed in, I apologize for that.
Professor, I have a question.
Sure.
So, just to clarify, are points going to be marked down if we write it like -7, comma, negative infinity?
Oh, you mean the question the young man asked earlier? I just can't see myself taking points off of that. I've seen that on tests, believe me. I don't like it because it's sort of going in the wrong direction. Right now, I'd give you a tentative, I would not consider that a wrong answer. But I'm gonna do a little investigating. And I'll give you a firm answer on Thursday.
Professor,
Wait. I don't like it, to tell you the truth. But I'm just not gonna mark it wrong. But I don't like it. I'll tell you the truth. Yeah, Stephanie, was that you?
yes, do we have to indicate the 0 on the number line, right?
No, not really.
We don't, okay. Because
I mean,
I just, because it's a negative, both negative, so in my head, it's automatically,
no, you don't need the 0. I mean, everybody knows where -7 is and -3 is. I'm just putting it there as a reference point, but it's not, if you left this out, if you leave this out, I'm not, I'm not upset by that at all. I'm not as upset about that as I am about the question over here. Because I like to think of mathematics as going from left to right, you know? I mean, here's the negative infinity, here's the -7, we're obviously kind of going in that direction. And then we pick it up again at -3, and we go over there. Just please, if it's not too much difficulty, get used to this.